Well, thank you, Dana, for having me. And yeah, I met the IDEAMAPS network in the KDD humanitarian workshop. I think 2 months ago, and yeah, I share that there is a great organization, and yeah, I'm glad to be here. So let me present. I'm Federico Bayle from Buenos Aires, Argentina. I have a Bachelor of Economics and a Master in Data Science here in Buenos Aires. So I will talk about the topic of this event and focus on technical aspects of our methodology and our whole project related to vulnerable communities mapping. So I am the co-founder and CEO of IDEAMAPS Labs. The IDEAMAPS Labs is a spatial technology company founded in Buenos Aires. Our focus is extracting insights for large areas around the Earth. We were founded in 2018 in Buenos Aires, and we were backed by UNICEF Innovation Fund and the government of the city of Buenos Aires. We are a software company, and we are creating an API to lower the barriers for data scientists and GIS professionals and people like developers to create machine learning models in spatial imagery using the Python coding language. We are supporting our infrastructure and our tools, our machine learning experience to lower the barriers to create this model with satellite imagery, SAR data, and that stuff. Linked in this presentation, you can find our GitHub repository. I will be talking about open source tools in this presentation, our Medium related to our blogs, LinkedIn, and Twitter. This is the main overview of our API and our tool. It allows GIS professional, data scientists, and technical people to upload their imagery, upload their annotations.
Yeah, sorry to interrupt you, Federico. I think we're seeing your background and not your slides. Can you just check which screen you're sharing?
Sorry. Oh, yeah. Yeah, I was talking with about the rocket.
Cheers, thanks.
Yeah, sorry. There. Okay. Thanks. Are you seeing the presentation? Yeah. Okay. Great. Yeah. Regarding the tool, the API. Okay, you can. The architecture. It's about uploading your imagery. Can be optical, SAR, thermal data, and the annotations. The annotations can be, for example, the polygons on vulnerable areas, but also can be polygon from school location, polygon for water bodies, and I don't know, crops, that stuff. So we provide the computing tools, like for the processing of the data, like the image tiling, the image rotations, and the reprojection and that stuff. And you can use that imagery to train your deep learning models. So the user only needs to be worried about choosing the different hyperparameters of the neural network, and we provide the platform and the computing side for abstracting that problem and helping them only to worry about the results and not how to deploy and implement the model. That is our tool. And regarding the case of vulnerable areas, let me say that the company, the very beginning of the company was my master thesis. This is the cover of the thesis. It's in Spanish here in the University of Buenos Aires. And my master thesis was about mapping slums and informal settlements in a district in Buenos Aires. So this was my first approach to this problem. I read a lot of papers of Monica, Richard Slusas, and that people, and it helps me a lot to understand the problem and the technological perspective. So in that thesis, I start using the more traditional machine learning techniques like decision trees and that algorithms, applying to high resolution imagery and some polygons regarding to vulnerable areas here in Buenos Aires. After the thesis, I think that this project can be scaled to different cities in Latin America. I think that there is a lack of data in the region regarding the location of that places and also update data. So I start the Action Labs with my other co-founder, Damian, and we start running the company to leverage the tools that I create for the thesis to different countries in Latin America. So at that time, we were backed by the UNICEF Innovation Fund to start scaling that model to different cities. So we scale the model to the main capital cities of Argentina, Paraguay, Guatemala, Uruguay, Honduras, and Peru. In this project, we will partner with the NGO Techo. It's an NGO in Latin America that have groundwork in the cities, and they survey the cities and create maps and data about the vulnerable communities, like the population, the polygons of the areas. We also partner with the Institute for International Urban Development. It's an institution in Boston, US, and with the social development ministries in Argentina and Uruguay, and also the IDB Bank. So this project was called AP LATAM. As we said, we team up with UNICEF and Techo, and our main focus was using only polygon data of informal settlements and satellite imagery, but also releasing the code of the tool as open source. So people in other countries can leverage the tool and the algorithm to apply it to other cities. Let me focus a bit in the case of Tegucigalpa, because regarding our partnership with Techo, they have data about Guatemala. It's a country close to Honduras, and in Tegucigalpa, there are not a map of informal settlements. So regarding our partnership with Techo, we create the first map of the city, of the vulnerable areas in the city, using only the data collected by the NGO in Guatemala. So we train our algorithm using imagery and data of Guatemala, and we apply the algorithm in imagery of Tegucigalpa. So we start iterating with the NGO to refine the map, making more better predictions, and validating in territory with the volunteers. So the project ends, the NGO create the first informal settlements map in Tegucigalpa, and I think it's a great impact of the project. You can find the website of the project here and the press releases for Tegucigalpa and Uruguay. This is the cover of the site. You can find here the maps as a web map, the data in a GeoJSON format, and the source code to clone the repository and start using our neural networks. There is here some papers that I used to my thesis and to the project AP LATAM. I think that there is a lot and great literature about this topic, and we apply it to Latin America and release our code as open source, but based on this academic work. A bit about the methodology. It's a convolutional neural network, and that we have some preprocessing steps like sliding windows and trying to solve the skewness of the distribution of the data using some sampling and that stuff. And also the post-processing regarding the dissolving the overlapping tiles and filter the tiles with low probability. Here you can find some technical reports about that. And right now we are working on releasing a new version of this neural network with a new net architecture to have more precise results. This is the link of the GitHub repository and the different scripts to start running the tools. This tool is in our repository and also in the Code for Development IDB repository. So, well, this is about the ground survey in Tegucigalpa. Finally, Techo found 42,000 families, and 42,000 population. Let me talk a bit about two different projects that we apply our algorithm in different contexts. This is a context in Manaus, Brazil, where we use our tool to map the informal areas, but also map the deforestation. And we found that the data set was seven consecutive drone imagery of an area of the city. And we found that the deforestation process as a predictor of the vulnerable community installation there. So we trained two different algorithms, an algorithm for deforestation and an algorithm for detection the vulnerable communities. We use IDEAMAPS. So we combine these two kind of algorithms to map this process of deforestation as a predictor of vulnerable areas. You can find this use case linked here in the IDB blog. It's in English and Spanish. The last project is about the same approach, but combining vulnerable areas and illegal mining in Lima, Peru. So we work with the UN and the Peruvian Spatial Agency to map illegal mining activities in the mountain in Lima, Peru, and intersecting that data with the with informal settlements detected using IDEAMAPS. So we intersect that two different problematics, and the whole map were created using machine learning models. But on one side, the illegal mining activities regarding the land use changes, regarding vegetation and that stuff, and also the informal communities around these illegal mining activities. So for conclusions, I think there is some topics important regarding the replicability of these methodologies in other countries. Also the technical skills required for GOV and NGO to use and reuse this approach, and well, regarding the expensive very high resolution imagery versus using other imagery like Sentinel-2, and the cost of running that regarding the GPU versus CPU approach. So thanks for having me. Thanks, Anna. And yeah, open for questions about that. Thank you.